Yes. Welcome back, welcome back.
Back to the future, maybe?
Oh. Future of autonomous cars, maybe?
Maybe.
Maybe?
Maybe.
Maybe?
Maybe.
Maybe.
Well,
Well,
Pavel Kanazirev. He has 18 plus years of experience in software development and automotive industry. He worked in Germany, Spain and Bulgaria, where he has taken multiple roles in different projects.
Pavel also volunteers in multiple educational initiatives. Minu Balkanski Foundation, Junior Achievement, Teach for Bulgaria, Professional Association of Robotics and Automation, Yambol Robotics Club and others.
So let's talk about the future. Ladies and gentlemen, Pavel Kanazirev!
Thanks for the warm welcome, and thanks to the organizers for inviting me today. Thanks also to all the volunteers who have made this event really happen. And also thanks to you, because you are allowing me to share some specific knowledge about automotive with someone. What was I thinking before starting to work in Bosch Engineering Center Sofia, developing perception devices for the future autonomous vehicles? I was thinking that it will be very hard for a machine to take actions on the road as good as the driver is doing this. And there were all types of questions related to the ability of the computer to sense the environment, to get the correct objects, to understand whether it needs to perform an action or not. And of course, how available this will become. Will the real-time algorithms succeed to capture the proper objects and to perform accordingly? While I was a student, there were amazing pieces of art trying to draw an anti-utopia. Movies like Cyborg, Terminator, or even music albums like Fear Factory's Obsolete were trying to predict a non-pleasant future where people may be under slavery on our planet. But I do not share this point of view. My understanding is that people and robots can very well cooperate together. There are already a lot of areas where we are using robots and we rely heavily on them. Why not engaging a robot in making a surgery on an area less than 1 millimeter? And what about why not hiring a robot to perform activities that are repeatable and tedious? Also, a very sacred place for a lot of software developers, the toilet. A lot of brilliant design ideas were born there, and also a lot of critical bugs have been root caused there too. But what about the maintenance? As it is not so pleasant, we can delegate this work to the robots, I think. Also, bomb disposal robots. They are very good sapers with amazing intuition who are able to disarm robots. But why not using bomb disposal robots? Everything that we risk in this case is just a piece of metal. And yes, the robots are already able to do everything that we are watching on the movies, cutting the correct or incorrect wire. When the topic about the cooperation became important for me, when I was small, I liked very much playing chess. So I was looking at the top seeds and their performance. In year 1996, IBM have designed a machine dedicated to beat the world chess champion. And it was a pleasure for me to watch how the world chess champion at that moment, Garry Kasparov, just demolished the machine. He was playing as if this is a sparring partner, not a serious competition. And I was so aroused that I went to my parents and made a pretty brave prediction that in the next 20 years, computers will not be able to beat the world chess champion. Unfortunately for me, the reality has proven that I am wrong. Even on the next year, 1997, with the improved version of the computer, Garry Kasparov lost. And with the time, we started to understand that when there is a proper set of rules, when there is enough visibility, it is a matter of time that the machines are taking better decisions than us. A new game was designed after this. It was called Advanced Chess. The rules were simple. A person together armed with his favorite chess engine is playing against another person armed with a chess engine. And these games brought the game to a very new level. It combined the best from both worlds, taking people's intuition and willingness of the person to create something beautiful, combined with the computer's memory and ability to calculate. Okay, I'm here today in order to prepare you to become competent consultants in case Luke Skywalker someday asks you what type of vehicle would he like. So let me check his user experience. He used to drive X-Wing, most of the time in autopilot, but also manual. I would not say this was he was very careful driver. Speeder bike, if you don't remember, his ride finished with him laying on his back on the ground on the moon of Endor. Jabba's shuttle was traveling together with Luke in order for his death sentence to be executed. So I'm not sure we can recommend something like him. But the Land Speeder is a perfect vehicle with which he's having good experience, and we can order for him something similar on the ground. Why not using just an improved automobile? What are the next big automotive steps? How will these technologies evolve? For sure, there will be wider electric vehicle distribution, depending on growing infrastructure and market improvement. Connected vehicles. In the century of the Internet of Things, we should expect that our vehicles will also be connected. Shared mobility. According to some analysis, in year 2030, around 10% of the vehicles worldwide are planned to be shared. Of course, autonomous vehicles. If you think the autonomous vehicles technology is related with all the three of the technologies that I've mentioned before. And the more and more intelligent software and the powerful hardware will really allow for a passenger to travel from one point to another without a driver's interaction. The evolvement of this technology is not a matter of over-engineering or striveness to prove that we can do something. This addresses real-world problems. For example, more freedom for people with disabilities. Or if you're like me, a father of children living in a big city like Sofia, every day you're concerned about the logistics of your family. How to assure the travel from home to one of the schools, to the other one, to the gym or to the stadium. Mobility for people not able to drive. They're very smart people who have just not invested time in taking driving license. Or another case, when we emotionally prefer to not drive, prefer to switch to autopilot. Like me the last time when I was driving in Plovdiv. Are there in the audience people from Plovdiv? Okay. Thank you guys. I love your city. I have studied there 5 years. It's amazing. But the last time when I was driving, people around me, the other drivers, were opening their windows, shouting at me, "Къде караш бе майна?" Which, if I need to translate to the non-Bulgarian speaking audience, is something like, "You're very welcome in our city." And mentioning something about someone's mother. A very common use case for me is to be able to go to a party with my own vehicle. At the end, we should not forget that cars are dangerous. And according to some statistics, in last year, around 1.3 million people have lost their lives in travel accidents. Even more, vehicle accidents are among the leading causes of death for people aged 5 to 29. And we know the root causes for them. If we look at them, we can easily see what will be the change in these statistics if we employ the autonomous vehicles. Speeding, significantly decrease. Drugs and alcohol reasons, totally disappear. Careless driving, not sure, maybe decreased. Lane change accidents, significantly decreased. Distractions, disappear. Driver fatigue, disappear. There are already technologies embraced in the contemporary automobiles that are helping us a lot. For example, lane change assist. What is happening when we are trying to make the overtaking maneuver? It is already feasible. This is a feature implemented and well matured just to put the lever and to wait for the indicator to light. After that, our vehicle is making the maneuver, or lane keeping assist, in case something is happening with the driver and his tire is on the lane. In this case, our vehicle can signal us. Our steering wheel can vibrate, or our seat belt too. This in case the driver has fallen asleep, he will be awoken. Rear traffic alert and front cross traffic alert for for crossing vehicles. In both cases, either we are on a parking or on the road, the corner radars are able to detect the speed of all of the participants in the traffic and to detect a potential collision. Pre-crash rear. It is also a function that after indicating that the collision will happen, it will fasten your seat belt and prepare the car for a crash. Going even one step more, already a technology is being evolved for opening airbag on outside. So in case the computer is predicting a crash from the left, for example, it can open the airbags on the left and decrease the power of the hit. Vehicle autonomy classification. The software, there is a society called SAE, Society of Automotive Engineers. They have developed a 6-grade scale for autonomy. And currently, most of the contemporary vehicles are covering level number 2. I would like to present to you on the next slide the progress that 2 of the major automotive companies are making, covering level number 4. All of this is happening, of course, in a controlled environment. This is why it is only level 4. But we have only one step to do, and this certification was made back in year 2019. So really, the future and the autonomous vehicles that are going to be on our roads are behind the corner. How does a vehicle, first, how a driver is taking a decision? Usually we sense, we think, we are planning the next maneuver, and we act carefully. So how does the computer does this? Almost in a similar manner. It uses perception devices for sensing, after that prediction algorithms for planning and thinking, and at the end it is safely implementing the plan. That means continuously watching for potential collisions. And in the next slides I will try to mention something for each of these devices that are used. And I cannot say that one is better than another one. Rather, combined, they are very powerful. And I really believe that with the good algorithms that we have, and with only these perception devices, we will be able to build these future vehicles. Ultrasonic sensors, using sound waves, which are of course not so fast, but this is why ultrasonic sensors are perfect to be used for parking reasons. Our vehicle is totally in control by using only them, and they are very affordable. Symmetrical positioning of the satellites, sending signals to the Earth, and are used by a lot of receivers in our vehicle, which can very well detect our current position. And Luke Skywalker here may be not happy when he understands that there is an error a couple of meters ago, but I hope I will try even to convince him after a couple of slides. Cameras and object recognition algorithms. These have matured very well. Already even hobby electronics enthusiasts are able to use such algorithms available open source and to detect many different objects. Thermal cameras. Maybe some of you don't know, but there are legislation concerns about driving at night. We are not allowed to throw light on more than 30 meters. So it is very hard, using only our high beams, to detect passengers on the sidewalk. And our goal for building autonomous vehicles is to have a very good picture in a radius of between 70 and 100 meters. So by engaging the thermal cameras, by starting to use them, this topic is very feasible. This widens a lot the perception of the driver. This technology is currently blocked by the US governments, but it has a lot of abilities. And my only concern in the ability of a car to exchange information with another car is that maybe they will build their own social media in which they will share how bad their drivers and owners are. LiDAR, a relatively new device. It is a mechanical piece on top of the roof of the car that sends and receives a laser beam on 360 degrees. Very good in object recognition. The only issue with the LiDAR is it is similar with the issue with the ultrasonic sensor, is that it is heavily affected by different weather conditions. Radar. Since radar is using radio waves, and we all know that they are traveling with the speed of light, they are much faster than the ultrasonic sensor. Why? Because the speed of light is 1 million times quicker than the speed of sound. This is my favorite type of device because it is very sustainable. It can survive most of the known weather environment implications. Inertial navigation systems. This is the device that will make it up for the incorrect GPS. Using not so complex mathematics and communication with the GPS from time to time, this can totally control our positioning. And this is very well used in cases like because of some bad weather conditions, or when we are driving in a tunnel, then this device is taking the control. The environment and the weather influence should not be underestimated. And this is why we are speaking about here about fusion systems for perception, not only one or another device. Object recognition. Do you know that in year 2013, it was a very popular case in Switzerland. One driver of Tesla have detected this picture on the right, driving behind a carriage. The horse's legs and the head of the driver were recognized as a person walking behind the car. Still, this was 9 years ago. Currently, no one complained about this, so I assume the technology has evolved. Also, important part of the object recognition is our perception devices do not only state we have recognized object here and there, but they also share the possibility. I don't know how is it in your countries, but in Bulgaria we have potholes. Some of them are with very good quality. And it is already the imaging sensors are so good that they're able to recognize them very well. And despite of the imaging sensors, there are two other ways to recognize. Also the vibration sensors and using 3D mapping. Okay, I have now a question for the audience, and I hope someone will answer properly because this will lead to a gift from our organizers. As you can see here, the radar prices back 22 years ago were around 7,000 US dollars. And now they are on average about 50 US dollars. So I need your assistance in order someone from you to try to guess what is the average price for a LiDAR, which is a relatively new technology. Now, any guesses? 25 US dollars. No, that's too low. Up. 200, up. More expensive. 500, more. One? 1 million. No, less. It's not so expensive. No one will buy this.
7.
How many? 10,000. Very close, just a little bit below. 8,000. Okay, 8,000 is the correct answer. We have a winner. And the reality is, this year, the legislation of the state of California and also the city of Beijing have allowed using the autonomous taxis. So this is already a reality. And this picture below is from a real example that happened a couple of months ago when police officers have stopped a vehicle and they were surprised to see that there is no driver. This raises also some other questions. Will it be really feasible for a car to drive not only without a driver but without passengers? How we will pay, how we will service our tires or load our reservoirs? Why I'm confident in this technology? We are using very nice graphical interfaces that are able to represent all of the information from the vehicle. And we are totally in control. I can walk you a little bit around. On the top left, we are seeing the different collections. This means objects are already sorted. What is the road sign? How many road signs do we see? How many dynamic objects, movable? How many static objects? We have enough information from our vehicle. What is our velocity? What is the angle of our steering wheel? Below, we are having the possibilities for each object to be recognized as either a pedestrian, a two-wheeler, or the other devices. Below, we are able to analyze among thousands of signals. And all of this is incorporated within the ability to map 3D using the information from the different sensors. Back to the main topic. What would be my advice for Luke Skywalker if he comes to the Earth and hesitates whether to take or not an autonomous vehicle? I would tell him that he must be sure and confident in his safe travel, knowing that R2-D2 is under the hood. Here is where we are. The main points from me today are driverless vehicles are a reality. They are here, and soon we will see them. We will be able to see them. Perception devices are of significant importance, and they, as a technology, they have matured enough. And algorithms for the future, for the vehicles of the future, are already matured enough. And part of them are made here in Sofia, literally behind the corner. Thanks.
Thank you. Thank you very much.
Any questions?
Yeah,
Everyone?
the topic was really interesting, and I suppose there will be lots of questions, but please ask just one or two questions because we're moving right next to the next speaker after these 1-2 questions. And you can ask Pavel everything you want in this topic and maybe something else outside in the coming beer break. So,
thank you, first of all, for the interesting presentation. My question is, you spoke about the low-distance communication modules that are not widely accepted at all. Assuming they are allowed in autonomous vehicles, do you have any concerns when this is allowed together with manually operated vehicles? If you do have such concerns at the same time, do you find any solutions in your opinion?
Thanks for the question. It is in reality, I'm not an expert in the radio technology, but as far as I know, there are real concerns about overloading the radio spectrum. Does this answer your question?
Any questions? Yes?
We have another question here.
Yes, thank you for the presentation. You spoke about for the internal navigation system and how accurate and for how long it is. I mean, because I can compare with, let's say, the planes, but for the automotives, how accurate and for how long you can use this?
The latest measurements are showing that driving 30 minutes on a terrain that is well known, on maps that are updated on the previous night, I mean relatively up-to-date maps, it is reliable. This technology is reliable for 30 minutes on a very well-known terrain.
Okay, thank you. Thank you very much.
Thank you.
Please applaud. Pavel Kanazirev.
Thank you. So, as we already said, in the coming beer breaks, we will have the opportunity to ask Pavel other questions. And now we have to fill in 30 seconds to switch the microphone. So if you have any questions to us,